performing the training portion of for the HVAC controls system for this building. First we'll review the equipment here on the graphics in the building, and then probably after lunch we'll do a walkthrough of the building and look at all the equipment, show you where your different sensors are and where to go to if something stops working, start getting a value that's not reading correctly or something like that. So you're familiar with where all your locations are. We'll also be providing you our marked up mechanical drawings that show all the wiring for the power, as well as the communication lines that go between all the controllers. So you'll have that for your reference. And it shows where on the floor plan, like your hot water and chilled water differential pressure transmitters are, and your duct static pressure probe, things like that. So with the air handler here, obviously, I mean, it's pretty much the same setup you're familiar with on the rest of your buildings as far as the graphics go. You've got your supply fans here, your coil representations here. This air handler has 3 supply fans in it, each one controlled off of a VFD. The speed is controlled. One speed signal controls all 3 fans, so they operate simultaneously. They're meant to all operate together. There's a mixed air sensor here right after the supply fans, and your hot water coil here, condenser water coil, and your chilled water coil. These coils are fed off of the this hot water coil is fed from the heat exchanger. If we go to this screen here, you can see the heat exchanger equipment here for that building, for this building. So here's the air handler coil right here. So this coil feeds these 2 pumps. Will circulate the water through the heat exchanger, which keeps this isolated. This has got glycol in this loop here, so that's why they put the heat exchanger in. And then your VAVs for the building are fed directly off of your campus hot water. The building pumps right here for all the VAVs and the heat exchanger, their speed is controlled off of the hot water differential pressure transmitter right here. And I'll show you when we do the walkthrough where it's located, but it's down on this level above one of the ceilings in one of the classrooms. So these pumps are set up on a lead lag schedule. So every 168 hours of runtime, which is basically a week's worth of hours, it'll rotate the lead pump. So it's only meant for one of these to be running at a time, unless, in this case where these are both on right now, it's just because there's enough pressure demand in the building that it's causing these 2 to run to give you enough flow. This heat exchanger valve here controls your water temperature out to your coil here. So this is controlled off of the discharge air temperature PID loop. There's a BTU meter up there that we've got monitoring your supply and return temperatures right there, as well as the flow that generates your BTU. This is total BTU consumption of the building. Then your condenser water coil here is fed from this equipment. So you've got your 3 cooling towers here. They operate simultaneously. It's basically one big unit. Each one of them has its own level sensor system on it. So it's basically one of those systems that, did they do the cooling tower training already? Did they go over how those sensors are set up in there? They got the probes inside the pipe. So you basically, you've got like a 2-inch PVC pipe that has a common probe that sits in the water all the time, and then 4 other probes that are at different heights. So you've got your first probe, which is like a low level, which is indicated right here, your lockout. So basically that means your water's too low, don't run any pumps. Then you've got your mid-level, there's 2 sensors for that, and that's your makeup call. So if the water gets below a certain level, it'll turn on and it'll latch the relay until it gets to the other sensor, which says, okay, there's enough water, turn off. And then, so that's what the makeup call is here. So if you see that makeup on here, that means that the water level is somewhere between those 2 sensors, and it's calling for it to make up. And then you got your high level here, which is the highest sensor, which means your water obviously is just too high in the tower, which we've got interlocked to the valve, so it'll shut it off in case something with the makeup sensor goes bad. That way you don't go spill over onto your overflow and just dump water onto your roof. So there's a set of those sensors for each tower, so they're all represented here. So if any of these makeups turn on, it'll open up the makeup water valve right here. If the air handler is calling for cooling, the first stage of cooling after the economizer is the cooling towers. And so it'll bring these on, as you can see they're on right now, and they're running at 37%. So they're maintaining the air handler's discharge air temperature to keep that satisfied at 53 degrees. We're monitoring the amount of flow on the makeup, and it totalizes here. And then your makeup valve position indication right here. You've got condenser water pumps right here, 1 and 2. They must have this one off up there. I'll have to go see what's going on. But obviously, if the status doesn't match the enable, then you'll get an alarm here showing that something's wrong. Indication of your temperature here, of what the temperature is going through the coil. There's a solid separator up there that runs whenever these pumps are running to filter that water through the solid separator. And then once a day, if these condenser pumps have been running at all during the day, at the end of the day, this valve will open up for 30 seconds and blow down that filter. There's a chemical feed system up there as well, and it's got its own independent blowdown valve that operates off of conductivity. So if your conductivity levels get too high, it'll blow down until the levels drop back down to, I believe it's below 1,000. Anybody have any questions on the condenser water system?
You may have explained it while I stepped out, but are they staging the
No, the towers operate as one tower.
Right. Okay.
So yeah, they come on together and turn off together
Okay.
because they have a common sump.
Okay.
You said the first stage after economizing is the high deck.
Yeah, the indirect cooling.
Yeah, and then you going into evaporative after
Yeah.
that.
So we go back to the air handler here. So then your next stage is your, it's actually evap, even though obviously the evap has to be after the chilled water coil, or all it do is condensate all your water out of the air and you lose your cooling. So, but yeah, the next stage after the indirect cooling is your direct cooling. So the equipment for this one is represented here. So basically you've got the fill valve, which will fill up the sumps, and then you've got the pump enabled, and we're picking up a status off. All 4 pumps have to be running up there for us to show status on. So that way you'll know if any of them kick out that you've got a problem up there. And then there's the fill valve, the drain valve, and the flush valve. So when there's a call for cooling in this portion of the system, then it'll first open up the fill valve, and there's about a 15-minute delay before it'll turn on the pumps. The pumps have their own internal floats, so they won't turn on until the water's high enough anyway. But this way you just don't see a call until there's a little bit of a delay to allow the water to fill the sump up. And then once it does, it'll turn on the pumps and it'll push the water up to the top of the evap media and circulate that down into the system. The fill valve stays open the whole time that there's a call for this, and then there's a float valve inside the tank, and I'll show you how all that works when we go up there. And that float valve actually controls the water level. And then at the end of the cooling cycle, the drain valve opens, and this will change once they modify the evap section up there. They're gonna put in a larger sump. Right now, the way things are, if we don't open the drain valve, the water that comes down from the media will overflow it, and then it spills out into your overflow. So, and then at the end of 5 cycles of the evap running, then we'll initiate a flush cycle at the end of the day, where it'll just open the drain valve and push new water up to the top for 15 minutes and flush all that media with fresh water and then drain it all out and let it dry.
The air handler continues to run through that.
Mm-hmm. Yep. Air handler's controlling off the speed of the fans, controlling off duct static pressure. So with the balancer determined that we need 2 inches, but I'll be adding a reset to this graphic screen because we actually need 2.5 when the large lecture hall on level 1 is calling for full cooling in that space. It needs more static pressure to get the airflow. But otherwise, when those cut back or when there's nothing going on in there, then the air handler is satisfied with 2 inches. If any of your safeties trip out, so you've got your high duct static, your free stats, or your fire alarms, it'll show us a safety alarm here on the screen, and that will shut down the supply fans as well as the outside air fan. All the outside air dampers will shut, and the return air damper will open. In your economizer section, this air handler operates a bit differently than you would typically see. The outside air damper actually operates off of flow, so it's maintaining enough airflow to make up what the lab exhaust fans are exhausting, bringing in enough outside air to keep your building positive. So it's allowed to cut back if it's satisfying airflow, but from what I've been seeing so far, a lot of the times this thing's going to be wide open unless it's super cold outside. Then it'll switch over to the outside air fan on this side here. This fan operates if it's below 44 degrees outside. Otherwise, it just stays off. So most of the time, especially in the spring and summer and fall, you'll be bringing in outside air through here. This fan here does the same thing. It modulates its speed to satisfy the airflow that's being exhausted. So you've got your total, right here is your airflows represented. So lab exhaust fans 1 through 4 are exhausting 80,000 CFM right now. And so we have to make that up by either outside air or return air. The return air is just a calculation of what the outside air coming in through the dampers minus the total supply fan CFM right there.
So on the return air, what is it? Is it controlled based on mixed air temp or what's it?
The economizer is a factor in it, in that if the dampers are allowed to cut back based on flow being satisfied, then the economizer, if it's calling for more, or less return and more outside air, then it'll, whichever the greater demand is what will control it. So you got your outside air damper flow here, your outside air fan flow listed, total outside air, and then lab exhaust, your return air calculated, and then total outside air and return air. Your fan controls shown here. Each supply fan has its own Vfd. So there's an enable, its status, and whether or not there's an alarm condition here for that fan. We're also tied into these VFDs through a LAN interface. So there's a yellow highlighted box around these tags here to indicate that there's a link there you can click on. So if you click on that, it'll take you to the screen that has the VFD on it, and it'll show you the other values that we're monitoring through that interface. I've also added here, just as redundancy, what's on the air handler screen as far as our physical points, so your enable, your status, and your speed. Any of the, just like in the other buildings, any of the points with the little white arrow here indicate that that's a point you can override or change. So there's a LAN interface for these 3 drives, for this outside air fan VFD, as well as the 2 relief fans. The 2 relief fans operate to maintain your building static pressure. So your set point is 0.05. As you can see right now, we're below set point, so we're not calling for them to run.
Where are the points that we're monitoring from as far as floors and for building static?
They are located, I believe there's 4 different corners of the outside of the building that we're monitoring, off of level 0. When we get up there, I can look on the mechanical drawings. They've got them drawn out where the tips are located.
Is there just one duct static pressure transmitter or sensor location?
Yeah, and it's located down here on this level. Any questions on the air handler?
On the safeties, how many, or what are all the safeties on that air handler?
So you've got your high duct static, your free stat, and a fire alarm.
That's it.
That's the safety loop.
You'll show us the free stats and.
Yeah. And these free stats are auto reset. So because of how big they are and where they're located, they're actually up on top of the air handler and they just come straight down because of the size of it. So it saves you from having to get a 20-foot ladder out to get up there to reset them. Any other questions on this piece of equipment? Okay.
Oh, one quick question.
Yeah.
Any kind of a humidity lockout on
Yes.
that section?
So we've got. Where's it at? Shown here. Exhaust air humidity right here. So it's, even though it says exhaust, it is the return air humidity from the building that we're picking up. So if this gets above 50%, it'll lock out the direct evap section
And we just sequence
to the chilled water. Evap setup, once it enables for the day, it stays on until the end of the day, or if the outside air temperature gets below 50. So that way we're not running that thing just because the day hasn't expired yet and driving our discharge air down to a point that's too cold. Well, that brings us to this screen, which is for the live exhaust fans. So you've got dedicated exhaust duct from each of the science rooms that are tied into the entire Phoenix system, and they all come back up through through a dedicated duct that feeds to these three exhaust fans. So they're isolated from the return air of the air handler, so it doesn't mix at any point. These three fans operate simultaneously and control off of the static pressure differential right here. So we're maintaining 3.3 inches of differential static pressure. That's relative to the pressure on the outside of the unit. Each of the filters, so let me go back to the air handler, I forgot to show you that. So there's a filter section here before the fans. There's one here before the heat recovery coil on the outside air fan, and then there's also one on the live exhaust fans before this coil. They each have a clean or dirty status shown here, as well as your differential pressure of that. These units are so big, your differential pressure on your filters is really low. So you're looking at closer to 0.2, 0.4 for a dirty filter status, whereas you normally be used to something being closer to 0.7, 0.6.
Those three big fans are tied directly just into the fume hoods only? Is there more, do they pull more from the building?
They're tied into you've got exhaust valves, yeah, the exhaust valves feed the hoods as well as
You've got,
there's exhaust in the room,
hoods,
right?
and then you've got a general exhaust in the room.
Okay.
So that when the hood's open, the general exhaust comes down and vice versa, because we're trying to maintain an offset in the room.
Just one duct for the general exhaust in the room?
Some of them have two exhaust valves in the room. It just depends on the room, the size of the room.
And then all the duct from each of those rooms tie together and eventually come back up to this point here. So I'll show you when we go up to the penthouse in the walkthrough, but you can see where the return section is, the return chase of the building, and you can see the dedicated duct that comes up and feeds right into that lab exhaust system. So there's a set of dampers here on the lab exhaust. There's a bypass section here, and then there's the section that goes through the coil. The coil section also incorporates the filter section here. So there's dampers on both sides of this section. This is to isolate that off so that when you're doing a filter change, that you're not in the exposed airflow. This part of this heat exchanger portion here, it only runs when we're running the outside air fan on the air handler. So this allows the air to be tempered coming in from outside. So we're taking advantage of the heat that we're exhausting out of the building and transferring that back over to the air handler without exchanging air. So when the outside air fan kicks on, one of these two pumps will turn on. As you can see, we've got a lead lag schedule here for those. And they'll circulate water either through the coil or they'll bypass it, trying to maintain 48-degree discharge off of this coil here. So that we still provide cooling to still take advantage of the free cooling on the outside air. So that's what controls the modulation of this valve here. And then same as the other fans, you've got your 3 Vfds here with your command, your status, and your fault condition here, and the speed. So all three of these fans control as one as far as the speed goes. And then you've got your airflow measurements on each fan shown up here as well. Any questions on this portion here?
On the transfer from that coil there to there,
Uh-huh.
how much heat do you anticipate that, or what temperature do you anticipate that loop being, like in January?
I don't know, we didn't have it up and going when it was super cold outside, and we had by the time we got the unit up and running, you know, our January was pretty mild, so we weren't seeing sub-freezing temperatures outside. But we were actually able to get, this valve actually didn't even have to be all the way open. I was able to get my 48-degree discharge without reaching its maximum temperature, or its maximum position.
The set point is at 48, is there a set point for it? That is this.
Or is that the discharge or set point for the air?
That's the discharge at this point right here. That's the set point for that.
Oh, okay.
That's a point I need to add to the screen.
I'm at,
And actually, I'll even add this sensor here to the, right here, so that you can see that sensor here, and I'll put the set point right here, so that you can see that that's what's controlling this valve.
okay. Yeah, one other question, you can go back on the back screen. On that coil down right there, what's that coil tied to? Is that to our building water or to the?
That's your heat recovery. So this coil right here, so if you click on this, it takes you to there, that's this one right there.
Okay, and is that the glycol loop, or is that?
I'm pretty sure they have glycol in that one. But there's also the glycol loop that's this one right here.
Right.
And that's this loop right here on this heat exchanger.
I didn't know if that other coil was tied into the glycol loop or the building water.
Yeah, this one's your building water, and then you've got the heat exchanger isolating it. So you've got your glycol in this loop here.
The other one picks up heat from the coil in the exhaust
Right.
and transfers it. That's the only heat source for.
Yeah, so since you're exhausting air, you know, and you're passing heat through this coil, it just picks that up, these pumps circulate it over and pushes that heat into here, warms up that water and dumps it into
So
here.
is that a closed loop?
Uh-huh.
And so it's not.
It's not tied into anything but
Right.
just these two right here.
Okay.
Just circulates between these two coils.
Or, okay.
Any questions on the lab exhaust fan? Then you've got the chilled water coil here. So that screen here. So there's two heat exchangers off of your chilled water coming from the campus. One serves that coil in the air handler. It's got a pump that circulates, that draws water off of the loop, circulates through that heat exchanger and back out to the campus line. And then there's another one on the glycol loop here for the chilled water coil. So whenever there's a call for cooling off of this coil based off of discharge air of the air handler, both of these pumps will kick on. This one here is on a VFD, so it'll modulate its speed to control the discharge temp. The other one's just constant volume. This heat exchanger here, it serves your process control equipment that's in the building that requires a cooling system.
So are there minimum requirements for that chilled water loop for the process controls? I mean, do I have to
We're still waiting to find out what that is. The balancer gave me a differential right now to maintain at 14 pounds, but once they get the equipment in, that may be reevaluated and a different number may be set in there.
Because what we get from the campus sometimes is, if the campus system isn't set up to be concerned about whether or not that loop has what it needs.
Right. Yeah, I'm not sure yet what we'll have to maintain or what we'll have to provide. In fact, the last time I was working with them on this, the equipment wasn't even installed yet, so I'm not sure if it's been installed yet or not.
And is that pump also, pump 11, ramp up and down based on the cooling demand for that, the secondary unit there?
Yes, which I need to add a set point here, once we figure out what that is.
Oh, yeah.
So we'll maintain the pressure to get the flow to all the equipment, and then we'll determine what temperature we need to maintain.
So you've already got a loop set up for it in that
Yeah.
programming?
This runs all the time, this section here, to keep that the equipment will have a constant load, so it'll need constant cooling running to it.
So will that be required even in the unoccupied hours? Should I
At least that's what I've been told. I'm not sure if the equipment itself will have a schedule, but we'll shut it off.
Eventually, the central plant is on schedule.
Oh, okay. Is it gonna be shutting down at night?
Yeah, the way it is now. So,
Well, I guess this will all be evaluated at another time.
Gonna do tuning every season change anyway, right?
Yeah. Let's see. There's some fan coil units. Let me go over the floor plans here. So we got your floor plans for each level. We broke them up into sections just so that you can see the rooms better, make them bigger. We show down here on your key what section of the entire floor this floor plan incorporates. So we've got some rooms where we're directly monitoring CO2. Your VAD, your room temperatures are shown here. And just like the other buildings where you've got your backgrounds that represent your temperature set point differential there. And your links with the thermostat that'll take you to your piece of equipment. I guess we could review this Phoenix valve since we're on the screen here. Go to one's 34. Let's see, it's 35. It's over here. Oh, is it near EC? There we go. Okay. So here's a room with a Phoenix valve in it. This one has a single supply valve, a single exhaust valve, and it's got a hood in it, as well as your air acuity monitoring here. So with the air acuity system, we're picking up values of CO2, VOC, and small particle count. And those values are directly shown here on the graphic. There's a purge switch in there. That's a mushroom switch on the wall, right?
Right.
Is it located by each exit?
Yes, it's located by each door, so that's hit, the room goes to full exhaust, shuts the supply off. And you also get an alarm on the screen.
Then the current flow of the current flow, your flow set point of your hood, your face velocity, sash position, flow alarm and jam alarm, discharge air of your supply valve, the mode that it's in. So if it's in, right now its terminal load is 0, so we're in a ventilating mode. If the terminal load goes negative, then this will change to heating. If it goes to positive, it'll change to cooling. And then we just show as a value here what that terminal load is. And your current flow set point, and if there's a jam alarm on the valve. You got your room temperature here, your set point for the room, and your effective set point. So this set point here that's shown is your occupied set point. I'll be adding unoccupied set point as well as a, let's see, we put standby in there as a writable value.
Standby as far as.
Standby set point.
The set points, when it's in standby, it just goes off occupied set points. It just adjusts the CFM set points.
Oh, okay.
So
So this effective set point that I'm getting back here, is that from the fact that the room's just unoccupied right
it
now?
is.
So is the occupied schedule based on a sensor or a schedule in the room for both?
We can do both.
Okay.
Right now, it's going off of sensor in the room, so if somebody walks in there, it goes occupied.
Question? Do you have a chart that indicates the numbers that are bad for CO2 and VOC and the particle count?
It's gonna be based off differential between outside air and inside, and that's how they're gonna tell if there's a lot of occupancy in the room or if there's construction particles in there. So it's based off of differential. I would,
I mean, if we look at the particle count and there's all those numbers up there, how do we know if that's good or bad?
you don't, I wouldn't concern yourself too much with the particle number, because if there's, like I say, it's gonna be based off of differential, what it does. So, I mean, for all you know, the outside air particle count's that same amount, and if that outside air is that same amount, there's nothing we can really do.
Okay, so it's a differential reading, not an actual.
Those are the actual readings, what it's reading, but the system is reacting off of the differential between outside air and what's being pulled out of the room. So, but those are actual physical readings. Yeah, I asked the same question to the air QD rep. I said, what's a bad number for particle? He says,
All relative.
yeah. He says it just depends. He says you might see, he's seen them as high as 1 million particle count, you know? So I wouldn't concern yourself too much with that number.
Good thing Geneva's gone, huh? Does that air QD system spit out an outside air particle count? Does it give us that value in there?
Yeah, I can, and that should be exposed. I'll
Okay.
show you what they are.
Because we could add that here on the graphic, and then you could have that to compare against, and then,
There's one per,
One.
for every floor.
okay. And that's its outside air particle count. Okay. So at least then you'd have an idea of what you're looking at to see if, you know, if it's, you know, if you're getting a lot of buildup in your room, or if it's just compared to outside, if it's relatively clean.
It's the same as inside. Oh my God, look at that. Ring, change food.
Any questions on the Phoenix graphic here?
Is there these Phoenix valves in the lecture hall, or is there a different?
No, they're mostly in the labs.
just in the labs.
Yeah, if it's an office or like a room like this, it's just a regular VAV box.
Fast carpet, it's probably a VFD
Yeah.
box.
What kind of,
That's a good way to tell.
what kind of controller is in this room then?
It's a lawn VAV controller.
Maybe.
Uh-huh. So just like you have in the digital learning center or the,
Okay.
I can't remember which other buildings are lawn. Is that the first one?
Yeah, maybe it is.
I think it is the
We've
first.
got lawn in the admin building, there's lawn being cleaned, got the trades.
Yeah, you'll soon have a lot more lawn coming, and maybe even some back net, huh? Okay. So this is fairly typical. There's some variations on the different. Some rooms have 2 of these supply valves. Some have 2 exhaust valves. Some will show a snorkel instead of a flow hood, which basically pretty much functions the same way, right? You
Right.
just- other than you don't have a SAS position. And, does it have an occupancy sensor? Like a snorkel? Is there a switch on it or anything, or is it just?
No, most of them are just constant volume. The main purpose of the snorkels is just to draw the heat off the equipment, whatever.
Oh, okay.
So most of them, I think, most of the snorkels are like 40 CFM.
So if they're like running a little burner or something, they just station that over it.
Right.
So there's your different levels here.
So, the CO2 stations there, are they?
We're just monitoring. We're not doing anything with them. They don't control outside air or anything. They were just something they added, I think, as part of a leads requirement.
Just the standard CO2 sensor that's tied in?
Yeah, it's mounted on the wall. There's one
right
over there on that
okay.
wall,
Got it.
right next to the space sensor. So it's got a little display on it, so you can see if it's matching what we're showing on the graphics here.
So are this lawn controllers, M&L controllers?
Yeah,
Those are tied into?
yeah. There's several up in the ceiling in the halls, and we've got those marked on the drawings where they're located, and we show where the wire pulls are for all those. This is the lecture hall I was talking about that's resetting the duct static pressure. So this one has 3 large VAVs in it. We monitor the damper position, so if it gets above 90% as that ramps up, then the loop will increase that, will reset that static pressure up to 2.5 to try to bring that back down. This is the only area that they fell short on air. Everywhere else in the building, they were able to achieve flow with 2 inches, so. And the greenhouse level also incorporates your penthouse. So you've got your unit heaters up here. Click on one of those, you can see, this is typical, there's 13 unit heaters located throughout the building. So they're on the DDC system. Space temp, your onset point and your offset point are shown here. As well as your enable, your status and your alarm condition. And then there's a hot water valve on there as well. We drive open and closed when the fan comes on. So the temperatures for the unit heaters are shown there. There's this area, as you come off the elevator, there's this area, open area here. There's the elevator equipment room. It has a rooftop unit as shown there. So we've added tags for all the different pieces of equipment here so that you know what equipment serves that area. This is your big air handler, and your live exhaust fans are over here in this section. The rooftop unit for the elevator equipment room it's just cooling only. So if the room rises above the 85, it'll turn on until, it'll stay on until it gets down to 75. And it just brings on the DX coil for that. We're monitoring the status of the compressor as well on that, so that you know if it's running. Unit heater in this storage area, and then there's a unit heater in the stairwell. There's a rooftop unit that serves this head house section of the greenhouse. The greenhouse section itself is all standalone equipment. All we're doing here is monitoring temperatures in these areas. They called for us to alarm, show an alarm on these temperatures if the space temp gets below, I think it was below 70 degrees in there, so. This rooftop unit for the Headworks building, it has both heating and cooling in it. It's got a gas burner in there, and a single stage of cooling. And it's actually located up on the roof of that head house section of the greenhouse. Or excuse me, it's located above this section right here, and then it's ducted into this room.
So is there a ladder on top of that to get up to the top?
Yeah, there's when you come up the stairs. Let's see, come out of the elevator. Right in this corner here. I'll show you when we go up there. There's a ladder that goes up on the roof.
Good, now we can get up there.
They're concerned about your
Man, always concerned about therapy, buddy. Need therapy.
Any questions on the penthouse level?
There's a little ice melt system for snow melters. There's that
Yes.
shine
Let's see. Did it not make it on the tree? Oh, there it is.
greenhouse.
So there's, up on the roof, I'm not sure if you've seen that, but where you exit the greenhouse on the west side of it, there's a walkway that goes over to the west stairwell to go down. That walkway has a snow melt system underneath it. When we go up there, I'll show you where the outdoor sensor is, right, that's represented right here. It's actually mounted on the handrails as you walk down that path. So there's a small heat exchanger up there, as well as a control valve, and we modulate that to maintain 90-degree water out to that loop. So when this turns on, there being a call for snow melt, this pump will turn on and this valve will open to maintain that temperature there to that loop.
Where's that melting,
What's that?
where's it melting the snow at?
Under the membrane of the roof.
On the walkway.
The heat exchanger up there for that snow melt's about this big. I think there's more volume in pipe than there is in the heat exchanger itself. There's some rooms that have humidifiers in them. So we built a matrix here to show all of the humidifiers. This is the room number that they're in. We monitor the humidity and we send a value represented by a 4 to 20 milliamp signal from our controller to the humidifier, and then we enable the humidifier. the humidifier basically pretty much runs standalone. So it's got its own built-in set point. And we can go to one of them. Have they done any training on the humidifiers? So they show you how to adjust its set point if you need to change it.
I thought that was on a separate system.
The set point?
The humidifier for the greenhouse?
No, for some of the labs have humidifiers in, those wall mount humidifiers.
The steam.
We've got alarm points here. If the humidity levels get below this range or above that range, it'll alarm that the room's outside of that.
So we're sending a 4 to 20 milliamp signal to maintain a humidity set point, or it's sending us.
We're sending a signal that represents the space humidity, and then it uses that signal to modulate itself. So it doesn't have a remote sensor.
Okay, got it.
We're the remote sensor, so it uses our signal to know what its humidity is in the room. We've got lighting panels in this building. So we've divided it up by levels. So level 0, there's 3 different panels. These are the circuits, the way that they're labeled, whether they're on or off. The LED here represents the status of the relay itself. This represents the command. Greg isn't on there.
So will there be an override capability for those individual zones
Yeah.
from that enable right there, or?
Yeah, it's supposed to be from right here.
Okay. So our electricians oftentimes want us to override lights now and again.
See if they're working
See if
right.
they're working.
Okay. Yeah, just like your other lighting screens, we'll have the override capability here. These lighting panels are through a LAN interface.
Which is
So
a G.
we're- So we're tied in that way.
No photocells, but
There are 3 photocells, and I need to add them to this. We just added them a couple of weeks ago. Originally, we thought all the lighting was going to operate just off of scheduling, but then we found that there were photocells up here, and so we just had to tie into them. They are tied into the logic. I just need to add them to the graphic here.
will they be controlled to everything or just certain sections?
There are certain sections, and I'll make a comment out here next to the zone that shows whether it's photocell or schedule only, so you'll know if it's supposed to be on or not.
One of the electricians was saying the other day that the outdoor walkway lighting is staging the lamps on based on the lumens or something like that. Was he was saying that's why certain groups of lights would be on at a certain
The outdoor lighting,
Yeah. Or,
we're only getting a contact closure from the photocells,
okay.
so we're either just turning all the lights on outside or off.
Okay. Based on.
Unless there's some lighting out there that's on a separate control that I'm not aware of.
We kept saying that to talk to you.
Oh, okay.
So, okay, there was a misunderstanding there.
Let's see. And then there's the generator screen here. That's an alarm. So we've got the generator and then 2 transfer switches, so we're picking up information on them. You get your run status here, generator available, connected, your frequency, power frequency, and then your volts between phases and your volts from ground to that phase. This is your list of alarms right here.
It's by lawn or factory.
This is also lawn. And then your volts and frequency on your transfer switches. So you've got the utility source. That was all went to 655. Your utility source and generator source. So when you lose power on your utility side, these will most likely go to 0. And then when your generator kicks on, you'll see voltage on this side here that is being supplied to the transfer switch.
Where are the transfer switches located?
They're right down here in the electrical vault.
Bottom floor.
There's one that's for emergency, and there's one that's general. That's pretty much all the equipment in the building. Any questions on that?
Are we in a trending stage right now,
Mhm.
phase for Jim?
Yeah. Yeah, we've had trend data being recorded for the last couple of months. But the clock didn't officially start until last
Monday.
week, yeah. Well, I guess we can go up to the penthouse and start walking through the equipment up there until we get to a point to break for lunch, and then we can pick up where we leave off and go till we run out of stuff to talk about. Where the damper is and the inlet of the fan, and then your output side of the air fan is in here. Coil in there. Yeah. So if you look, the coil is on one more section down.
What did you say these VFDs control here?
These control your tower fans, cooling tower fans. So if you look right here, they're labeled on the drive door. The equipment that controls.
Laser pointer help you at all on higher spots?
This is your chemical feed system for the cooling towers. It pretty much runs all standalone. It's got its own monitoring. It'll inject the chemicals into the water based on the conductivity needs. There's a blowdown valve right here on the condenser water, which this valve is tied directly into the chemical feed controller. So it determines when it needs to open. If you look on the controller, you see your conductivity level display here. So it's trying to maintain, I believe, about below 800. So if it gets above that, it'll open up the valve. Then you've got your solid separator right here. There's a blowdown valve for that located right behind it. So this is the valve I was talking about that we open once a day if the condenser water flows have ran at all during that day. And it just opens for like 30 seconds. This pump runs whenever one of these two pumps are off. So you're constantly filtering your water in the cooling towers. Keeping the scaling and sure if they got it checked out for a reason or not. This is exhaust train 1. So this is good sign up here, sir. On the side of the building. This goes all the way down to the floors. So we can control the start and stop, monitor status. Right. It's located in the electrical room. Level 1 and level 0. Kind of egress. Stairwell. Right inside there's an electrical room. And there's a starter in there for that. This feeds all the bathrooms on this side, and the one over there feeds the bathrooms on that side. Right here, these are the BTU meters that I was showing you on the graphics. So this is your hot water BTU and your chilled water. This is showing your current flow on these right here. What's that? We can actually scroll and see what our BTUs are. I'll have to find out. We're tied into this through the interface. These are actually backnet. So we've got a network connection to each one of these. So these actually have their backnet ID. So they each have their own IP address. And the sensor itself, this is hot water. So there's your ultrasonic sensor. And then the temp sensors are up there. It seems down into the insulation. Chilled water is located right here. Dfds for the supply fans right here. This one's your outside air fan right here. And these Dfds here are your hot water pumps. Pump 5 and pump 6. Of course, these are for the building. So they also feed the heat exchanger for the coil on it. And then you've got pump 7 and 8, which are on your secondary side of that heat exchanger. They're constant lock. Yeah, they come out of the MCC. So these just disconnect power between the MCC and the motor. There's several glycol tanks up here. So we're monitoring alarm on each of these. Just a single alarm point. So if any of them go into alarm, you'll get a common glycol alarm up here. So you have to come up here and see which one of them has the alarm light on. So this is heat exchanger 2. This is your hot water heat exchanger. So this serves the hot water coil on this air hammer. And this is the modulating valve for it. So off of pump 7 or 8, you'll circulate through here on the load side. This is on the primary side, so this is coming off of the load with 5 and 6 feet. So we'll modulate this to maintain your discharge air handler, discharge air temp on your air handler. This heat exchanger is heat exchanger 1. That's chilled water coil heat exchanger there. This is the one where we modulate the speed of the pump. It doesn't have a valve on it. So if you look here, you've got your VFD right here. So this is your VFD for pump 3, which will modulate to maintain the chilled water temperature so you can maintain your discharge air. Pump 4. Then you got your disconnects for pump 5 right here. These are the two pumps that operate to control your process control chilled water off the heat exchanger 3. Right over here. So it's just that little guy there. So there's pump 12 right there, and then pump 11 right there. Those two pipes right there, that's where they go into the outside air heat recovery coil. So that's the coil that shares off the lab exhaust. So you got your pipes coming in right there, and then they go across and then through the pumps over there, to then feed over to the coil in the lab exhaust. There's your snow belt heat exchanger. That is, yeah. For that. Right there. Yeah. There's your pump and valve is right there. Oh, okay. See the plugs going over to it? Right. Getting above that. This is very loud. Yeah, this pump is on or off, and then we modulate the valve to maintain the temperature. You got the temperature sensors.
Talk real loud.
Temperature sensors are located right here. Put supply and return on that secondary heat going out to the snow melt zone. So this section here is your lab exhaust. You got a question? I didn't catch it. Oh, okay. So that's your snow melt heat exchanger right there. That little tiny guy. We've got temperature sensors on the supply and the return that monitor the water temp going out to the pump. The valve for it is right above that pipe right there. And then the pump for it is right there. This is behind over there. This is your vacuum system for the lab. So this, you got your, we'll go on the back side of the air handler so you can see better how this is ducted. But basically behind here, when the duct comes up through the return case, that's your isolated exhaust. It comes through this section here, and then it's drawn in and up and down. So you got your 3 exhaust fans and airflow here. Just push the air right up and down. So your VFDs for the 3 exhaust fans right here. And the airflow stations for the 3 fans are right here. What are these rating? Airflow. So you got airflow in each of these 3. here's one of the dampers I was showing you on the graphics. So right now we're open to this side. And if we look inside here, sorry, inside here. So you can see that set of dampers is shut. So we're either flowing around the coil, this is the bypass section, or inside here, you're flowing through the coil itself. So there's a set of dampers here, and then there's another set on the other side of the coil.
Yeah, but trying to change these filters is probably during the season you're not using the coil.
That would be best, but there is an override on the graphic if you need to change them during that time that will temporarily bypass.
Switch them.
Well, that sucks. Can't we just shut them down? That's the fun part. Then you get all the calls.
That's right.
I'm not sure what the protocol is if you have to shut down the lab exhaust, if they have to shut down, I'm not sure. It calls for the lab exhaust fans to run all the time, so.
Yeah, it's probably put all the exhaust hoods in alarm.
Yeah, and you start venting stuff you don't want to.
Yeah. It's like the Beersey building, they don't want to ever shut off.
Yeah. And if we go back here where the inlets are of the fans,
We were saying that.
so right inside here is where we have the probes for the airflow station. They're just across the inlet here. So if any work ever has to be done on these, and they're just tied with the copper tubing here, and it goes back to those airflow stations that I showed you mounted on the outside of the unit.
Okay.
So there's a set of these in each one of these three fans.
Okay.
Here's the other dampers. You can see, so when this side's closed, the other side of the coil is closed as well. All three dampers operate off the same signal.
Just to position.
So you're either one side or the other. See your coil in there? This is your coil section, kind of a V shape, so it looks like this on the other side as well.
It's making a lot more sense.
Yeah. Hands off. Any questions on this unit? Those are blowout doors in case the pressure here gets too high. So they'll just open up and allow the excess pressure to exhaust out.
My question down there is there glycol in this coil?
Yes.
It's glycol.
It's in that loop, that whole loop that goes between the two coils.
Okay.
Right here's your filter differential transmitter for the exhaust fan for your coil.
What did you say was the number for that?
I think we're at 0.2 with dirty on these. Because we're running at like 0.08. Because it's just so big that, you know, your airflow over that surface area is pretty low. This is the lab exhaust 4. This serves that little radioisotope room. It's got the radioactive stuff in it. Yeah, I think I got to do this one runs at a fixed speed all the time. Set by speed. Yeah. And you pretty much added the VFD just so that they can set the speed where it needs to be as well. What's that?
Is it room 156?
Oh, yeah. Pipes that I was showing you that went over to that coil, they come over and go in right there. That's your supply and return right there. When we go back that way, I'll show you where the valve is. You guys ready for me to turn this back on? Generator fires up, it will keep two of them going to provide minimum exhaust.
So it's a UNC over there on generator?
What's that?
Is the UNC on generator power?
Yes. All the DDC panels are on generator power. So when we shut off power, I went through and did an audit of everything I can still want to. It was pretty much everything. There was a couple unit heaters and some little things like that that weren't coming up, but everything up here, all the humidifiers, anything we had to interface to, all that was on that panel. So pretty much everything that we need to see and stay up. There's a UNC for each floor. This one for this floor is located here. The other ones are located in the network room on each of the other 3 levels. There's a network switch here, so we're bringing in those dynasonic, ultrasonic flow meters. They come in and tie in here, as well as this guy. So we got the UPS here for to keep the panel powered up, as well as the UNC while we're waiting for the transfer switch to kick over the generator. There's a UPS on each floor as well. Is that a jack specifically for? This is tied into the building network. Now there's empty ports on the back here if you want to just plug right into your network. We're only using 4 of the 8 ports, so in each of the floors have at least 1 spare port on them, so you can go to a network and you can just plug in. There's a switch like this in each network that we provide. So you got your lab exhaust, duct static right here. The probe is located, when we go on the other side, I'll show you. It's located on the back side as the duct comes up to the floor. Your duct static for your air handler is here, and your building static transmitter is here. Here's one of the unit heaters. This is typical of the 13 unit heaters. It's got a coil right there that you water circulate. There's a valve right there. Turn on, and then you'll have your wall stat right there. Below the unit heater. Yeah. All 13 up here and in the stairwell. There's 2 of them over on the east stairwell. Most of them are on this section here. And I show on the floor plans where the unit heaters are located. There's a tag for each one of them so you know which number it is. We've got our outside air intake section right here. So there's this damper section here is for your outside air fan, which, like I mentioned before, it only opens when we're below 44 degrees outside. And then this section here is your regular outside air damper intake. Mounted on the outside of that section is your airflow station for that damper section here. And this ties back to that panel, that white enclosure I showed you on the other side of the unit.
What are those? They just sensors?
Yeah, this airflow station uses differential pressure to calculate its airflow. So the differential pressure across the expanded metal, calculated with the square footage of the area for the intake, generates its calculated CFM.
Where are the free stats?
Let's go tight air sensor here for the building, and it also measures your humidity.
That one sensor does?
Mm-hmm.
Both of them.
Yeah.
That's new.
Yeah, this is a Visola device. So you actually have a digital readout of what you've got as well.
And then what does it send back to the controls? Just a 0 to 5
0 to 5 volt for
You
each of them.
just calibrate it to...
Yeah, it's they gave us the ranges for the temperature, and then the humidity is 0 to 100%.
Yeah. Wow, it's kind of nice.
Yeah, it's a Cadillac device. The return air right here. So the return air comes up from down there, drawn down here and pulled in through right here.
That's it.
That's it. So this guy and that one up there.
Oh, that's right, there's
But
one.
you can see that the return air on this air handler is significantly smaller than the outside air because of the amount of outside air that we're exhausting through the lab exhaust.
Right.
We're having to make up a lot of outside air, so there really isn't a lot of return.
Okay.
Pretty much just, I mean, if you think about your ratio of VAVs versus your Phoenix in this building, it's about a 1/3, 2/3 ratio. And so you're really only returning your room's return air that has regular VAVs in them.
That makes sense.
And even then, if it's not being made up by outside air for those rooms. So if you look inside here, you can see the averaging sensors for the your mixed air right here. There's 4 of those sensors that go across the coil to average out to give you your mixed air temperature. Freestats are located right here, so you can see them stacked up right there.
Okay.
And then they're just spanned out across the coil in several different pieces. They're auto reset, so if they trip, you don't have to come back here to reset them.
What about the static pressure resets? Is there a...
Yeah, it's down here.
Oh,
High jump static pressure switch right here.
That's the one that we tripped on.
Yeah. So if you have to come to this side of the unit while it's running, you can walk on the intake side of the fans. That's the easiest section to get through, because you can pretty much open that door without any resistance. The airflows on that side of the fans are actually really low. You just walk through and it just feels like a breeze. So then you've got your discharge air duct. So we've got our discharge air temp sensor right here, and then your humidity sensor right there.
Was that since you said it gets about 50%, that's the cooling tower?
That's on the return, which is located inside the lab exhaust fan here. So you've got, see this duct, how it comes up here, is enclosed in this unit, goes down. So this is your isolated lab exhaust duct right here. So this ties into all the Phoenix exhaust in your building. And then this area right through here, in the open area, is your regular VAV return for the building. This is your probe right there for your lab exhaust duct static.
Is that installed for the return?
Yeah. And then right here are your 2 new relief fans. And they've got the 2-position damper motors in front of them. And then the VFDs for those relief fans are right here. They were running when we were, that and when we were bringing in, when the return still open? Yeah, when the return was shut, then it was pressurizing the building and we were exhausting more. But yeah, they won't really have a high demand. It would be pretty much exhausting most of the air through the lab exhaust. And a lot of the VAV outside air will be going into the halls and then going into the lab and getting pushed out that way. So see the duct going up through the roof from that lab exhaust fan, that LEF4. So this is where it comes up, goes up across, and then goes over and back and down to that exhaust fan intake. Any questions on the air handler or the live exhaust fan?
These are the release fans.
Yes.
What trips them off just high
Yeah,
static pressure?
The building static pressure. So when it gets above 0.05, it'll turn them on. The dampers are two-position, and then the fans will modulate their speed to maintain the pressure. Okay, so this is the direct evap section. So we've got several valves in here. Right here is your fill valve. So that will send water through the pipe here up into the sump sections here. And then inside the sump section, you've got your float valve right here, which controls the water. This is your actual fill valve right here. That's in series with our valve right down there. So this actually, when that fills up, it'll send pressure to this head and shut it off. Kind of a water actuated valve. These pumps here, you can see the floats on the outside here. So when the water level's high enough, that'll enable them to come on if our enable's turned on from the system. We monitor status. There's a CT on each one of these 4 pumps, and then they're wired in series. So if all 4 of them are running, then we'll show a status on the graphics. There's there's 2 drain valves here. That'll one for each side. And this valve here is your wash valve. So this allows water to go up into the top, follows that pipe and goes into the top of that header there, and then also goes up into the top of the 2 headers up on either side there. And that'll just push water right up to the top and just wash down.
You said it'll flush at the end of the day, or you said 5 cycles?
After 5 cycles, at the end of that day, of the 5th cycle, is when it'll initiate the flush sequence.
Okay, so what is 1 cycle? What is
1 day.
1 day?
Mhm.
Okay.
So basically, after 5 days of direct evap, then it'll flush the system out. Any questions on the evap section? Okay. We monitor overflow. So we've got a sensor inside of this pipe, one inside of this pipe to detect water overflowing, meaning something's wrong, we're filling up the sump too much. And then there's also this tape sensor on the floor that runs along here that monitors water on the floor. This green light here, you see that flashing green right now? If that turns to red, then that means that it's detecting water. So you can use that as a verification against what we're showing on the graphics if there's any question as to what the sensor's doing. So we got the 3 cooling towers out here. Like I said, when we reviewed the graphics, they all act as 1 tower, 3 separate cells. You see all the pipes tied together, common sump, common supply coming back to them at the top there. You've got your sump heater in the cabin for each tower. You've got a handoff on the switch on it. The smaller boxes there are for your relays for the level sensors. So you got the level sensors are inside that gray PVC that plug out, you can actually open it up. A lot of water will come out right now, of course, but you can see the longer probe. If you look in the top there, take the lid off the top, you can see the probe going down into it.
What kind of probe is it? How does it?
It's an electrode. Oh, so there's one that's actually the common, and then you got 4 more at different levels. So all it does is just make the circuit, okay, when the water gets to that level. Okay. Is it a boric sensor? I think so. Okay. There's his Eco. We ran it through all his paces, they work really good. Temperature sensors on the sump of each of the towers, so we're monitoring what each one's doing. And the sub temperature, we controlling that off the contact closure, maintain water temps. It's all controlled off the air handler discharge air. I mean, to prevent freezing. Oh, it's got an outdoor air sensor on the intake, so it's factory. Yeah. All year round. Pretty much, yeah. I mean, out, when it's cold outside, we probably won't need them. Yeah. But if for some weird, you get a warm day, you can just turn them on. Right behind you here is the rooftop unit for the elevator equipment room. Remember, is the controller for it in here? No, it's inside. I'll show you where it's located. There is a filter differential sensor in here that we show on the graphics what the filter differential is. And up on the roof, the access from inside to get the rooftop unit for the tent house building. So that panel there is for the rooftop unit that feeds this room.
Okay.
And then that one is for the greenhouse
Okay.
rooftop unit. So here's the ladder I was talking about that goes up on the roof. That'll get you to the rooftop unit up there.
Is that the only piece of equipment up there?
Never been up there, I don't know. Right here, and feeds into here, and you have your return up there, and our sensors right here on the wall in this room,
Where's the sensors?
right here. And the other 3 bays are all on the greenhouse controls. If we go over to the next one, I'll show you where our sensor is if we're monitoring temperature. So each of the rooms, we've got one of these weatherproof boxes with a probe coming out that we're using to pick up space temp.
That's all we do, right?
Yeah, we just monitor the temperature and that's it.
Is it on tritium?
Yeah. But all this stuff here is all standalone. It's its own system. So this is the walkway that's got the snow melt system underneath it. And then the sensor's right here, mounted on the handrail. So that picks up the snow and will give your enable to start the system. They had to put this in for egress because of the greenhouse, so they put the snow melt in to keep this path clear so you can get over to the other door if you have to. So 2 of the 3 photocells that we were monitoring are in here. So one of these is for, I can't remember which is which. One is for outdoor and the other one is for this west indoor. So it monitors the lighting in the atrium down here on the west end.
And they're a function of the GE controls, not the.
No, they're tied, well, yeah, they're, because of their, the way that they function, they're designed to work with these. So we tied it into the input of the last channel, the last two channels,
Okay.
and that's how we're getting our status. So we monitor these channel, these relay outputs, and so when these channels turn on, or these relays are turned on by what would be pretty much like a light switch turning it on, then we see that output turn on, and we know that that photocell is enabled. Because they're a pulse on, pulse off type contactor on the photocell.
So there's an actual lens or something out here that's
Mhm.
receiving the light.
Right. So that goes back to these.
That goes back to those.
And then we're tied into these. These are the panels we're tied into through the lawn. We're tied in right up here at the top.
Oh, okay, there it is.
So this is typical for all of the lighting panels throughout the building. I believe there's one on each electrical room on each floor, on each side. So there's one on this side and there's one on the east side in that electrical room.
Did you say there were 3 photocells?
Yeah, the other one's in one of the electrical rooms on the other side on level 2. And it's picking up the ambient light.
In the big area?
Yeah,
Okay.
that area over there.
The photocells for these are located, one's on the roof and one's
Mhm.
in here.
Yeah.
Okay.
So all that is a contact closure then for this.
Yeah, it pulses on and off, so that gives it this
Oh, that's what you said.
start. So you can see that light's on right now.
Mhm.
So it's calling for lighting inside, but the roof one is off. Okay, so each of the network rooms on level 0, 1, and 2 are just like this setup here. So we've got a UNC in each of the rooms, as well as a UPS to keep the UNC running while the transfer switch switches power over, so that all the DDC stuff stays up and running. There's an Ethernet switch here that's tying in the equipment together.
There are only 2 UNCs for this building?
There's 4.
4.
Yeah, so there's,
They're all in the
They're-
same?
yeah, with the exception of the penthouse, which was down on that end by the live exhaust fans where I showed you that UPS,
Okay.
where our panels are down on that
1, 2, 3.
on that west end.
4.
Uh-huh, yep. And then of course you have the Phoenix stuff and the Air Acuity system above you there. They've got their Jaces inside the cabinets there.
Is this the hard stuff?
This, I believe this is access control for your doors. If I had to guess. Okay. So we've got labels here that show that the chilled water differential pressure as well as the CO2 controller are right up here above the ceiling grid.
Where's your flashlight, Ray?
So you can see there's an M&L 800 right just a little higher up right there. And then the differential pressure transmitter's right there. As well as a VAV box right here, so.
There's all sorts of new stuff now.
Pressure sensor controls the process chilled water loop. Where
For the whole building?
that comes off that heat exchanger 3.
Okay.
So remember how I was talking about there's that small loop that has the chilled water just being supplied to the process equipment.
Oh,
So we're maintaining differential pressure for that loop so that we make sure that all the equipment gets fed water for that. But other than that, the only other place chilled water feeds is the coil up on the air handler.
okay.
So that's all that controls. It doesn't have anything to do with the pumps for the air handler itself.
Okay.
So we're in room 044. Okay, so right above this tile here, it's marked hot water differential pressure. There's another one of those transmitters just like the one that was in the hall for the chilled water.
Is this for the whole building?
Yeah. So this does your entire hot water loop for all the VADs as well as your coil upstairs.
Is that labeled up there?
It is. Yeah, there's a label right there, right behind the speaker.
Over here.
This is one of those emergency push buttons that Matt was talking about, the purge switches that show up on the Phoenix system. So if we push that, it'll show up on the
Push that, you get an
graphic.
automatic go fast air removal.
Full exhaust, no supply, yeah. Transfer switches, we're tied into these, communicating with them through the lawn. We're tied in right here, onto the lawn board there.
Is there an enable or override the generator on, or just?
There's the possibility of it, but we haven't.
No direct wired up again.
No, it automatically gets a signal that the generator communicates with the transfer switches through the lawn back and forth themselves as well. And then we monitor stuff with that same connection.
We can't turn it on at this moment. If the maintenance.
No, it's just a matter of linking up a couple of objects, and we could.
Okay.
Because I actually had it hooked up at one point just to test it, and Enable does work, so. I know it's got its own internal time clock, and I'm sure it's got its built-in start sequence once a week, but we have done buildings where they have us tied to a schedule and we'll do it off the DVC system. So if you wanted to, that possibility is there. Right here, up in the ceiling, that transfers air from out of this room when it gets warm in here. So on the graphics, you'll see a transfer fan in your listed equipment. That's where this is at, is right there.
There's a fan up there on the roof. Or is that?
Yeah, it goes all the way up. Goes all the way up. Transfers the air out. Up inside this panel is where the lawn's tied into for the generator. So if you undo those two screws right there on the right side, that swings open to the left and you can see our lawn wires in there.
So all these devices are showing up on the lawn chart then?
Yeah, so that generator screen I showed you on the graphics, that's where all those points are coming from. That's from the connection here. So if you need to troubleshoot where the connection is, that's where to come to, is right here. So if you need to get a hold of me, you can contact our office at 801-990-1950. My email address is sreynolds, S is in Scott, REYNOLDS, at utahyamas.com.